All right, so we're looking at surface area and volume of a sphere to start. So perhaps some new shapes that you may have not spent a lot of time on. First of all, we're going to go back to stuff that you have done. So taking a look here, we're going to find the surface area of this cube. So it says the label on a very special bottle of paint states that it will cover 50 centimeters squared. Should there be enough paint in the bottle, or would there be enough paint in the bottle to paint the outside of the cube as shown? So think about back in junior high, you talked about the net of three-dimensional shapes. So what would the net look like? So all of these sides are the same. They're 3 by 3, and there's 6 of them. So if you were to draw the net, we have some magic happening here. There you go. There's a net of a cube, 6 sides the same. Okay, and so what's the area of each of the sides? So they're squares. So here, just give me a sec here. So surface area will be 6 times the area of a side, or a face, whatever you want to call that. So 6 times 3 times 3. So 6 times 9 is 54. Okay. And that is centimeters squared. Okay, and so that's the surface area. Then we take a look. The paint in that special bottle covers 50 centimeters squared. So therefore, no, there won't be enough paint. Okay, because 54 is greater than, I want to move this out a little bit. There we go. 54 is greater than 50. So there won't be enough paint. So that's a prism. It's a special prism. It's a cube. Then the next, would there be enough paint in the bottle to paint the outside of the cylinder? So surface area of a cylinder. Remember, you have 2 circles here, okay? And this curved face is really a rectangle. So again, we have a little bit of magic happening, I think. There's the rectangle, okay? And there's the circle, okay? Now, those are technically, so that would be at the bottom. These are on the wrong sides here. Okay, so we could have this rectangle being, if this is basically this height is the same as this one, then this would be at the top, and then we move this one. Could just move it down there, right? Okay, it's got to be touchy. Or they could be at the same end. It doesn't really matter because they're circles, right? But in any case, we have to get the area of that entire, all of that red part. So there's 2 circles. So surface area equals 2 times pi r squared, the area of a circle, plus the area of that rectangle. Well, what is the area of the rectangle? This length here is actually the circumference of the circle, okay? So there's the length if you look at it as it's rolled up. So circumference is 2 pi r, and the height of that, we'll call it the height of the cylinder. This would be your h, okay? So 2 pi, now here the radius, we actually have to calculate it because we're given the diameter. So radius would be 1.25, and the height is 4.8. Okay, so in your calculator, let's just move this over. Okay, clear off what you have. So 2 pi times 1.25 squared plus 2 pi times 1.25 times 4.8. Okay, so that's 47.5. This is our final answer. So 47.5 centimeters squared. So that is less than 50. So therefore, there would be enough paint in that bottle. Okay. All right, the next one, it's on the next page, is a sphere. Okay. So it does say to watch a demonstration. So you can go to YouTube for that. You can copy that in, and I'll let you do that rather than me going to watch it right now. This link actually might work here. Let's just check it out. Yeah, it does. It's got some fun music, but basically it's estimating, let me turn it down a little bit. It's estimating the surface area of a sphere. So I think you've probably done that before with an orange peel, but I'll let you watch that. So I'm going to close out of that. It's got fun music though, and let me get that back up. In any case, the surface area of a sphere is actually 4 times the area of this inside circle. So the area of this inside circle, which is not on the outside, but it's in the inside, the cross section of it, if you multiply that by 4, you actually get the surface area of the whole sphere. So it's going to be 4 pi r squared. Okay. And so in this case, we're given the radius, 2.1. So when we calculate this, it's going to be 4 pi times 2.1 squared, and 55.4 centimeters squared, and that is more than 50, so therefore not enough paint. Okay, so those are sort of surface area of 3 basic shapes, common shapes that you have to work with. So just a reminder, the definition of this surface area, so is just the total area of all surfaces. Actually, yeah. Oops, sorry. Surfaces. So if it's a 3-dimensional prism or pyramid, those sides are all polygons. So you just add up all of those areas of the faces or the sides. And then if it's something curved like a sphere or cylinder, you have to have other formulas to calculate those, but it's all of the surfaces. So I always think about if you had to paint it, like that last question, what would you be painting? All right, so sometimes you're not given a picture. It says a sphere has a diameter of 12, determine its surface area. So right away I find the radius, and so surface area of a sphere is 4 pi r squared, so that's 4 pi times 6 squared. Okay, so you can do that on your calculator, 4 pi times 36 in your head, and nearest tenth is 452.4 centimeters squared. Surface area is always units squared. Surface area of a sphere is 400 square inches. Determine the radius and diameter. So now we're working backwards. So now we know the surface area, and we have to calculate the radius. So we want to divide here by 4 pi. Okay, and then, okay, so now r squared is 400 over 4 pi. It says to the nearest tenth. What you can know, because you can do is keep it exact. 4 goes into 400 is 100 over pi, right? So that's r squared. And then really you could simplify that. You could have 10, when you square root, 10 over root pi and then rationalize it. But it does say to the nearest tenth. So in any case, to get r, we have to take the root. So get your calculator out. Let's go 4. So if you were to go back to the 400 over 4 pi, let's go back to that to make sure that you remember the brackets in your denominator. Okay, and then square root. Okay, and so I square rooted the unrounded version, so I kept it in my calculator, and then I got 5.6. So don't round it first, just like in trig. Okay, and that's going to be just inches. So therefore, diameter, keep it in your calculator, and then multiply that by 2. So 11.3. Okay. All right. Then volume. Okay. So again, think about volume as filling up the object inside, the space that it takes up. So how much water would it take to fill this cube? So volume of a prism is, any prism is area of the base times the height. Now for a rectangular base prism, it's length times width times height. And for a cube, it's basically length cubed, okay, because they're all the same. So in this case, this is going to be 3 cubed, which is 27 centimeters cubed, okay. And just a fun fact, 1 centimeter cubed equals 1 milliliter. So that would be, you'd fill it up. Often when we're dealing with liquids, we fill up with milliliters. So that would take 27 milliliters. Okay. Next one is a cylinder. So again, volume, sorry, started with an A there. So volume is the area of the base times the height. Well, what's the base? It's a circle. So pi r squared times h. That's always going to be the volume of a cylinder. So here, remember that radius is 1.25. So this will be pi times 1.25 squared times 4.8. If you ever need to stop the video, go for it, right? That's what it's all about. So pi times 1.25 squared times 4.8. Okay, that's 23.6 centimeters cubed. Okay, then the next is a sphere. And again, you can watch that demo, but once you've watched it, the volume of a sphere, okay, is going to be 4/3 pi r cubed. Okay, so always think, because there's the surface area of a sphere and volume of a sphere. If you didn't have a formula sheet with you, you know it's got pi in it, you know they've got 4's in it, you know they've got the radius in it, but if it's volume, it's cubed, 3 dimensions. If it's area, it's squared, 2 dimensions. And this volume of a sphere, it's got those 3's there. So that's how I kind of remember that. In any case, 4/3 pi times 2.1 cubed. So this one I'll do here. So just go 4 divided by 3 times pi times 2.1 exponent 3. 38.8. Okay. All right. So then it says the volume of a sphere is what the volume of a cylinder with the same radius and height. Okay, so take a look. If we look, if we look back at our last page here, Now this wasn't the same. Sorry, I got to go back one more page here. Oh, maybe I got to go back. Okay, so here, this is what I'm looking for. Okay, so pi r squared times height is the volume of a cylinder. All right, now we're told that the sphere fits in here. So that means the diameter of the sphere has to be the same as the diameter of the circle. So maybe I'll just show it here. So it's going to be a wider, and then your sphere is going to be in there, right? So when we think about that, volume of a cylinder would be pi r squared times the height, which is going to be 2r, the diameter, and volume of a sphere is 4/3 pi r cubed. Well, if we simplify this, we get 2 pi r cubed. And so really, all the difference is we're multiplying the volume of the cylinder by 2/3 to get the volume of the sphere. It's going to be smaller. It's 2/3 of the volume of the cylinder with the same radius and height. Okay, and then for volume, that's just the amount of space an object takes up. Okay. Okay, so a sphere has diameter of 12, determine its volume. So the radius is 6. So volume of a sphere is 4/3 pi times 6 cubed. Enter that. It's going to be 904.8 centimeters cubed. Okay, volume of the sphere is 400 cubic inches. Determine the radius. So we're working backwards from volume now. So 400 equals 4/3 pi r cubed. So really you're dividing here by 4/3 pi. Okay. And so then we're going to end up having, so just be careful, so that's going to be 3/4 times 400 over pi. So I just kind of flip the fraction part of this. I mean, you can do it all in your calculator, but I like to simplify it, right? I'm a math teacher. So pi r, oops, my pi should be gone here because I divided. Okay, so then I get basically r cubed equals 300 over pi. And so now to get r, I need to take the cubed root of 300 over pi. So this one I'll do on my calculator here. So remember, cubed root, math, down to cubed root, and then 300 divided by pi. That's all underneath the radical. Then cursor out, and that's going to be 4.57. So each to the nearest tenth, and then multiply by 2 to get the diameter. So so notice on this that the radius will be 4.6 when it's rounded, but the diameter truly is going to be 9.1, right? So I'm not multiplying by 2 on that, right? I multiplied it by the unrounded part, and this is inches. Okay. All right, hemispheres. Well, it's exactly half of a sphere. So how does the surface area of a hemisphere compare to a full one? Well, the outside curved surface is divided by 2, and then we have to add in the base, which is a circle. Okay, so how does that look? So surface area of a sphere is 4 pi r squared. So we're going to divide that by 2, and then we add in a pi r squared. Look at what happens here. If I simplify that, that's equal to 2 pi r squared. And if I add in a pi r squared, then I get 3 pi r squared. Kind of cool. So you can remember that. That's not on your formula sheet, but if you want to, I always remember it just as half of the outside surface plus a circle, but it does simplify to 3 pi r squared. Now, how about the volume? So it is easy, it's just half. So it's the volume of a sphere divided by 2. So that's going to be 4/3 pi r cubed divided by 2. So what's that going to be? Well, the 2 goes into the 4 twice, so it's going to be 2/3 pi r cubed. Okay. And here's some examples. What is the surface area of the hemisphere shown to the nearest whole number? So those are in inches, 48. That has to be the same as this. Okay, if it's truly a hemisphere, the radius all the way around of any sphere has to be the radius of the inside circle. So surface area will be, if you remember, is going to be 3 pi r squared. So 3 pi times 48 squared. Let's do that on your calculator. That's a big number. Okay, to the nearest whole number is 21,715 square inches. So for imperial, they often put it in words, square inches. Okay. All right. Oh, yeah, and that's it. Okay, so we're done. A little intro on surface area and volume.